Assalamu alaikum and good evening, everyone. Yesterday we have completed the class till here, and now we have to start with question number 3. Liquids that contain molecules of tea smell like lemons. Okay. Molecule of tea exists as a pair of stereoisomer. If you see over here, this carbon has two similar groups. So it helps me to identify that the stereoisomer over here is going to be optical, not cis trans or geometrical, because the double bonded carbon must have two different groups in order to show cis trans or geometrical isomerism. And optical isomerism can be shown by this carbon, because if you see, this carbon is chiral. Is this understandable to all of you? So that's what they have asked you in the next part. Name the type of stereoisomerism shown by molecule of T. Explain your answer. So it's optical isomerism as one of the carbon atom has four different groups. Okay. Now, part B. Two organic products are produced when a sample of tea is heated under reflex with excess of acidified concentrated magnate. So if you recall, when this happens and there is a carbon-carbon double bond, so this from this the molecule breaks apart. Draw the structure of two organic products from this reaction in the boxes. Okay. So if you see over here, it is going to be break from here. And when it is going to be break from here, this carbon has both the sides carbon chain, a methyl group over here and a methyl group over here, which means that this part is going to turn into a ketone and actually a propanol. So this part is going to have this. We are going to show it like this. Is this understandable to all of you? And if you look at the rest of the structure, so we have 1, 2, 3, and over here a side chain, and then fourth, fifth, and here we have a aldehyde, right? So K acidified potassium magnate is an oxidizing agent. So on oxidation, it turns aldehyde into a carboxylic acid. And if you see this carbon, over one side there is a carbon chain and the other side there is a hydrogen. So this carbon is also going to turn into a carboxylic acid. So I'm going to put a C double bond O over here and then OH. Is this clear to all of you? Okay. Now, see, figure 3.2 shows two reactions of T. Okay. Here we got a reaction 1 and here we got a reaction 2. Okay. If you see in reaction 1, it's an aldehyde and that is an alkene. And if you see over here in reaction 1, alkene stays the alkene, but aldehyde turns into alcohol. So it means this reaction is a reduction. Is this understandable to all of you? Which one aldehyde? You are talking about this one? You are talking about this one? Yes. So see, it's a heat under reflex, and remember, in heat under reflex, never aldehyde is formed. Aldehyde is formed when heating followed by distillation. And this carbon has a one side carbon and the other side hydrogen. So this carbon is always going to turn into carboxylic acid when heat under reflex are the conditions. Okay. Okay. So we have identified this reaction as a reduction. Now reaction two, if you see in reaction two, okay. If you see in reaction two, it's an aldehyde and it's an aldehyde as well, right? On both the products, we are getting aldehyde, and but where the alkene is there, on that carbon, we are getting alcohol. So it helps me to identify that this is the reaction in which we have added steam in it, and it's an electrophilic addition. So one carbon got the hydrogen and the other carbon got the OH. Yes, Umar, see, it's a chiral carbon. There is a one CH3. This is the second group. This is the third group. And over here, there is a hydrogen. Okay. So it's an electro reaction to is electrophilic addition. Okay, now they are asking identify a suitable reagent for reaction one, and reaction one, as we have identified that it is a reduction, right? So for this reduction, as aldehyde is being reduced, so either we can use NaBH4 or you can use LiAlH4. But for example, if carboxylic acid is being reduced, because aldehyde is turning into an alcohol, let me recall you guys. You guys, I think you are not reviewing the, lectures and notes. When we have discussed the oxidation reaction, if you see over here, where is the oxidation reaction? So in oxidation, you see whenever alkene is being oxidized, you are not getting any alcohol, right? Or do you? When alkene is oxidized, diol is formed, not a simple alcohol is formed. Otherwise, you are getting carbon dioxide, aldehyde, no, yeah, carboxylic acid, and a ketone. So that's why it's not an oxidation, it's an electrophilic addition. That's what you have studied when an alkene turns into a simple alcohol, that is an addition, electrophilic addition. Look over here. Please give me a minute. Yes, Banin, did you understand? Okay. So, okay, now identify the reagents and conditions needed for reaction two. So reaction two, we need steam. Either you can write steam or write a gaseous symbol with the water. And for beside this, we use a catalyst. And the catalyst over here is H3PO4 and heat or high temperature. Okay. Now, third part, suggest which product formed in reaction two as a higher yield. Explain your answer. So if you see over here, here we are getting OH on this carbon, and here we are getting OH is on this carbon. So if you recall, OH is the one, a negative ion or a nucleophile, you can say. So obviously it is going to attack on a carbocation. So it means in Q, this one is the, this carbon actually became the intermediate carbocation. And if you look at this carbon, on this carbon, there are three alkyl chains, which means it is going to be it was a tertiary carbocation. Is this understandable to all of you? And in the same way, if this carbon got an OH bonded to it, so it means this is the carbon which became a carbocation as an intermediate. And if you see on two sides, there is a alkyl chain, which means it is going to be it was a secondary carbocation which is formed. Is this understandable? Yes, are these 2 points clear to all of you? So we know that carbocation is the, you know, tertiary carbocation is more stable than the secondary one. And in Q, the intermediate was a tertiary carbocation, which has a more alkyl group, hence more a positive inductive effect, and due to which the positive charge of the carbocation or the charge density of a carbocation is reduced. So Q has a higher yield because its intermediate is tertiary carbocation, which is more stable as three alkyl groups are attached to it, causing greater, or you can say higher, positive inductive effect leads to decrease in charge density of carbocation. And when the charge density of carbocation decreases, it becomes stable. So it's less likely to attract by the nucleophile. That's make it stable. Decrease in charge density of carbocation. Okay. Now D part. Separate samples of Q and R are added to a separate test tubes containing acidified potassium dichromate and heated. So if you recall, it's an oxidizing agent. Okay. So interestingly, if you see, this is an aldehyde. So it is going to oxidized to COOH, right? And this one is a, if you see, secondary alcohol, right? So it is going to oxidize to ketone. And what was this? It was an aldehyde. Okay. This one is aldehyde as well. It is also going to oxidize to carboxylic acid, right? And this one, if you see, it's a tertiary, isn't it? So this tertiary alcohol is going to oxidize to nothing. It stays the same because tertiary alcohol doesn't oxidize. So what they are saying, Now let's have a look at the question. Predict the observation for each test tube. Explain your answer in terms of functional groups present in Q and R. So obviously the reaction has been taken place, right? So in both test tubes, in both Q and R, solution, what is the color change when dichromate has been used? Can anyone recall? Solution turns from, yeah, turns green, but you have to show the whole color change. So turn from orange to green, right? In both, aldehyde is a CHO group, right? Oxidized to COOH. In R, secondary alcohol oxidized to ketone, but in Q, it was a tertiary alcohol does not oxidized. Okay. Now, part 2. When PCl5 is added to a separate samples of Q and R at room temperature, both reacts vigorously. Complete the equation to show in figure 3.4 to describe the reaction that occur when reacts with PCl5. So with PCl5, OH reacts. So if you recall, that it's the nucleophilic substitution because OH has a negative charge, so it is being substituted. So the negative charge means it has a lone pair of electrons. So the subspecies containing lone pair of electron always, when they get substituted, it's a nucleophilic substitution. So the rest of the molecule, sorry. So the rest of the molecule remains same. Here we got OH. And beside this, the rest of the products are HCl and POCl3. And due to this HCl, if they ask you the observation, you will write steamy fumes because of HCl, okay? Now, part 3. Suggest why sample of Q and R must be dried before PCl5 is added. Include a relevant equation to support your answer. So, yeah, it's obvious you have studied this in periodicity in period 3 because we need to dry it. Otherwise, PCl5 reacts with water, or you can write that it hydrolyzed, and they ask you to support the equation. That is equation you have studied in period 5. When PCl5 reacts with water, we will get phosphoric acid, H3PO4. And beside this, we get 5 moles of, sorry, not 2, 5 moles of HCl. And for this, we need to put a 4 over here. Okay, is this understandable? So see, the whole is organic, and the last part they have asked you from, period 3 equation. When? From where, Bunny? Oh yeah, that's what I am telling you, and I mistakenly right, because the substitution would occur, so OH is displaced by Cl. Thank you, Bunny. Okay. Is this clear to all of you? Now we are left with question number 4. Compound V is a liquid. V contains 77.2% carbon, 11.4% hydrogen, 11.4% oxygen by mass. V has a relative molecular mass of 280. Calculate the molecule of V. Okay. So first, from the percentages, we are able to calculate its empirical formula, right? So carbon is to hydrogen. oxygen. Carbon is 77.2. Hydrogen is 11.4. Oxygen is 11.4. In the first step, we divide these percentages with the relative atomic mass of the atoms. So I'm going to divide it with 12, divide it 1, and divide it with 16. Can anyone divide the numbers and tell me the answer, please? So here I'm going to get 11.4. The two other values. And it's not H removed from OH winning, the whole OH is removed. It's a nucleophilic substitution. 6.43. Okay. And for the last one, it's 0.713. So the smallest value is 0.713. So I'm going to divide all the values with 0.713. So here I'm going to get 1. Can anyone tell me the rest of the two values, please? 9. And the second one? It's 16. Okay. So from this, we got the empirical formula, right? Its empirical formula is going to be C9 H16O. If I ask you to calculate the empirical formula mass, can anyone calculate it and tell me that it is going to be 9 times 12 because 12 is the AR of carbon, 16 hydrogen's AR is 1 and 16 for oxygen. So 12 times 9 is 120, 108, 108 and 32 is 140. So we got the empirical formula mass 140. Is this clear to all of you? Then we will find the value of N, and the value of N is equals to MR over empirical formula mass, right? So MR they have provided us 280 divided by 140. So the value of N is 2. It means that the molecular formula is going to be C9H16O times 2. So when I multiplied it with the carbons are going to be 18, the hydrogens are going to be 32, and oxygen is going to be 2. Is this understandable to all of you? If any one of you has any question, any query regarding this, please ask. Okay, now B part. We contains two types of functional group, a carboxylic acid and an alkene. Okay, so it means in this compound there is a COOH and there is a C double bond C. Describe a chemical test and observation which confirms the presence of carboxyl functional group. Yes. So if you have to, no, Banin, that's not wrong. It's wrong. 2,4-DNPH is used for a carbonyl, not carboxylic acid. It's for aldehyde or ketone. Yes, very good, Hassan. Uh, Mix. Yes, very good, Umar. Mix V with sodium carbonate, or you can write any other carbonate because acids reacts with the carbonates only. And the observation which confirms us that it's, acid is effervescence. Observe. So as the effervescence form, it shows that it's a uh, carboxylic acid. Okay. Now, next part, 2. A 3.196 gram of bromine reacts completely with 2.80 gram of V. So see, bromine, if you recall, this bromine or any other halogen reacts with the alkene only. And they have told us that there is an alkene in compound V. Calculate how many alkene functional groups are present in one molecule of V. Okay. So it's very easy. Find the moles of V first. It's 2.80 gram divided by its MR, and the MR is 280. So what I got, it's 0.1 mole of V has been used. Is this understandable? Now, these are the moles of V. Now calculate the moles of bromine. The mass of bromine used is 3.196. And if we look for the AR of the bromine, it's 79.9. So there are two bromines. What will be the mass then? 80 and 80, 80, 160, which means 159.8, if I'm not wrong. Yes, the MR of bromine would be 159.8. So can anyone calculate the answer and tell me the value? Okay, just calculate it. It's, I think, 0.01, not 0.1. Yes, Amna, do the calculation again. I think you are getting the wrong answer. It is going to be 0.02 mole of bromine. Till here, is this understandable to all of you? Now, see, from this, what we can able to understand that if there are 0.01 mole of V and it is reacting with 0.02 moles of bromine, if there is a 1 mole of V, then how much moles of bromine has been used? Moles of bromine would be 2. So if 2 moles of bromine would be used, then it means that there must be twice of carbon-carbon double bond. So there are two carbon-carbon double bonds. So the number of alkene functional group in V is 2. Because if you see, let me show you. If there is a one, for example, this is the whole structure like this. And there is a one carbon-carbon double bond. So it is going to react with 1 mole of bromine. And as a result, where there is a double bond, it got single bond and both the carbons have a bromine in them. Now, if you look at another compound and we have its 1 mole, but if you see, there is a double bond over here and there is a double bond over here. So with two double bonds, we need 2 moles of bromine. And as a result, here we got a bromine. And then after this, here we got a bromine and then a carbon. Is this understandable to all of you? So if you are able to identify with the 1 mole of that compound, how many moles of bromine have been reacting, it shows you that how many alkene or carbon-carbon double bonds are present in that. Now C part. W, X, Y, and Z have same molecular formula C5H10O. W, X, Y, and Z are added separately to different reagents. Observation for these reactions are described in table 4.1. Okay. So W, orange precipitates, okay, with 2,4-D and pH. It means from here I can, that it has a aldehyde or ketone is present. But when with aqueous alkaline iodine, there is a no change. So it means CH3C double bond. Oh, this group is not present. And orange precipitates with Fallon's reagent. It means it's an aldehyde. Is this understandable? And the molecular formula is C5H10O. Okay. Now again, aldehyde and ketone is present. Aldehyde and ketone is present. Yellow precipitate is seen. It means that in this CH3, C double bond O group is present. Right? And no change, it means no aldehyde. And if aldehyde is not there, then it means that it has a ketone in it. Is this understandable to all of you? Now, W, X, and Y each contains a common functional group. Name the functional group that is present in all three compounds. So the common one is carbonyl, because aldehyde and uh, ketone both are collectively called carbonyl. So the common functional group that all have, which is identified by 2,4-DNPH, with 2,4-DNPH, all of them showing you orange precipitate, which means they have a carbonyl functional group. And carbonyl means either it's an aldehyde or a ketone. Now part 2. State the formula of the yellow precipitate produced when X is added to alkaline iodine. So the yellow precipitates are of iodoform, and the formula of iodoform is CHI3. Is this clear? Now, W could be one of the four structural isomers. Draw the skeletal formula for two possible structural isomers of W. Describe the type of structural isomerism shown. Okay, if we talk about W, its molecular formula is C5H10O, right? From W, we have identified it's an aldehyde. We have further identified that CH3C double bond O is not present, right? Now, they are asking you to draw the skeletal formula for the two possible aldehydes. Okay, with the 5 carbon atoms. So 1, 2, 3, 4, 5. I made the 5 carbon atoms. I'm going to put a double bond O over here. That is the isomer 1. Now, what I can do, instead of making a 4 carbon atoms long chain, I will make a 5 carbon, instead of 5, I'll make a 4 carbon atoms long chain. I put one as a branch and keep the double bond over here. So what type of structural isomerism it could be? It is a chain isomerism, right? Because the functional group are at same position, and one has a 5 carbon atoms long chain, and the isomer 2 has a 4 carbon atoms long chain, and one is in branch. Is this understandable to all of you? Now, part D. Figure 5.1 shows the mass spectrum of ketone Z. Okay. Figure 5.1. Use the information in figure 5.1 to suggest the formula of the fragments Me peaks at 29 and 57, reduce the identity of Z. Okay, Z is a ketone, so it means there is a C double bond O and possibly 5 carbons, so it could be like this. No, 1 minute. Have a look at Z. No, it's not Z. Okay. But if you see, we are getting one fragment at 57, right? And the other fragment at 29. So I have to identify. So if I assume Z, let's say, like this, CH3, CH2, C double bond O, CH2, CH3. Why did I so? Because it's a ketone and there are 5 carbon atoms. So first I go with the simplest one. Okay. Now, if I break it, if I assume that it could be break it from here, and we got these two fragments. So if we see this fragment is C2H5, and if you see this fragment is C2H5CO, just calculate its mass. There are 12 carbon atoms, which makes 12, 24, and 5 hydrogens. So 12 plus 4 is going to be 29, right? So we are getting 29. So it means over here, it is this fragment has been formed, which due to which this is signal we got. And now over here, it's 29 plus 12 plus 16. So 12 and 16 is going to be 28, 29 and 28 is going to be 9 and 8, 7, and 17, 2 and 2, 4, 57. So C57. So it means this signal is due to C2H5CO fragment. Is this understandable to all of you? So it means that reduce the identity of Z and the formula of the fragment. So the one fragment which is at a mass over charge ratio of 29 is C2H5 positive, and the other one is C2H5CO positive. And when we connect them, there are 5 carbon atoms and the third carbon has atom has a has a carbonyl. So it is going to be pentane 3 on the identity of Z. Is this understandable to all of you? Okay. Now, one more thing. If a student do like this way, for example, CH3, if a student assumes that there is a double bond over here, or the ketone is over here. Now, if you break it from here, for example, there are two carbons, which makes the mass 24, one oxygen, which is 16, and one and three hydrogen. So what would be the total mass? 40 and 43. Are we getting the fragment of a 43? Yes? No. So it means that fragmentation would be wrong. But if you break it from here, so see, this one is C2H5. And if you calculate its mass, two carbons makes it 24, five hydrogens makes it 5, so 29. And if you calculate this one, that CH3, CO, CH2. So three carbons makes it 36, one oxygen 16, and five hydrogens. So 36 plus 16, 42, 52, 52 plus 5, 57. So see, you are getting the same mass over charge values. So if the student identified these fragments, and as a result, it will identify the ketone would be pentane 2 on, then it is also going to be a correct answer. Is this clear? So that's how we are identifying, Fatma. See, we have identified these two are the fragments. So when we connect them, isn't it, we got this? So see, it means that could be a Z. So I have made pentane 3 on. But see, we have work on this. If I break here, I have made pentane 2 on. And I tried fragmented over here from here. This fragment got the mass of 29. And this fragment is getting the mass of 57. So if you will write C2H5 positive, and then you will write CH3, CO, CH2 positive, and after that, from this, these fragments are can be obtained from pentane 2 on, not pentane 3 on, right? So you will write pentane 2 on. So this is also going to be the correct answer. Okay. So here we have ended the paper. And we are left with we have started the October number 2322. We done with the part 1 and the part 2 has been left. So we will be continuing it on Monday. Okay. So see you everyone on Monday. Take care. Best of luck. And whatever queries you have, you can WhatsApp me. Allah Hafiz.